Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this already, if you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 485. Please turn to page 485. On page 485 you will see three problems, 12, 13 and 14. These are all difficult questions. Question number 12 and 13 are level 4 problems. On a difficulty scale of 1 to 5 they are classified as level 4. Question number 14 is a level 5 problem. I want to start with 14 first and work our way backwards. You understand? We'll do 14 and then 13 and then 12. What concept are they testing in question number 14? That's the first question we need to answer. Every time you come across a question in the SAT, ask yourself, what are they trying to test here? What are they trying to see that I understand? The concept that they're testing in question number 14, what makes this question a level 5 question, is this concept. It says, the opposite sides and angles in a triangle are always proportional. Notice, opposite sides and angles in a triangle. What kind of triangle? Any old triangle. It doesn't have to be any particular kind of triangle. It doesn't need to be a right angle triangle or an isosceles triangle or an equilateral triangle or an obtuse triangle or an acute triangle or an ugly triangle. Get it? Acute, ugly. It can be any triangle. As long as it's a triangle, as long as there are three sides coming together, then in any triangle, opposite sides and angles are always proportional. What does it mean? It means that the largest side in the triangle, will face the largest angle. Or the other way around if you like, the largest angle will face the largest side, which is why in a right angle triangle, the largest angle is the 90 degree. That's the largest angle, and therefore the side facing the 90 degree, which is the hypotenuse, is always the longest side in a right angle. In a right angle triangle, the longest side is the hypotenuse. Why is that the longest side? Because it faces the largest angle. And the smallest side in a triangle will always face the smallest angle. That's the concept that they're testing here. Now what they tell us here is that the triangle that is given to us is an isosceles triangle. They tell us that a triangle ABC is an isosceles triangle. But they don't tell you which two sides are equal. They don't tell us which two sides are equal. All they tell us is that two sides in this triangle are equal to each other. But they also tell you that side AB has to be bigger than AC. AB has to be bigger than AC. Well, obviously those two sides cannot be equal to each other, which means AB has to be either equal to BC or AC, the smaller of the two sides, here. AC is smaller than AB. Maybe the smaller side, AC, is equal to the other side, BC. These are the only two possibilities. These are the only two possible scenarios. But let's see what happens in these two scenarios. Which is why, listen carefully, which is why they give you 5 answer choices here, and the question simply is, which of the following must be false? Which of the following must be false? I just read the question. I just read the punchline in a very cursory manner. We'll come to that in a second. Don't worry about it, what that means. We'll keep it in abeyance. We'll come to that in a second. I just read the punchline in a very hasty manner. Which of the following must be false? Can you tell me what is the most important word in that question, in that punchline? The most important word in that punchline was must. There are 5 answer choices there. The question is, which of the following must be false? That's their way of saying that the other 4 answer choices that you see may or may not be false. Other 4 answer choices may or may not be false depending on how you draw your triangle. But there is one scenario that is going to be always false out of the 5. Our job is to locate that one scenario. Shall we? Let's take a look. Now we know that the opposite sides and angles in a triangle are proportional. So therefore, we know now that since we are told that AB is greater than AC, that implies that the angle angle facing AB. Can you tell me which angle faces AB? Well, if you're looking at this scenario, this is A to B, A to B. The angle facing the side AB is this angle right here, angle C. Angle facing side AB will be, AB is greater, will be greater than angle facing side AC. Can you tell me which angle faces side AC? There is your side AC at the bottom here. The angle that faces side AC is this angle right here on the top. That's angle B. So what we have established here is that angle facing side AB will be greater. Angle facing side AB is angle C. Angle C will be greater than angle B. This is what we established, and that is a fact. That will remain the fact, that will never change in this triangle, whether we are dealing with this particular scenario or that particular scenario. In this scenario also, you can see the angle C here, angle C as you can see here, is far larger than angle B. Why is angle C larger than angle B? Because angle C faces the larger side. Angle C faces side AB. Angle C faces side AB, which is the longer side. We are told AB is longer than AC. Therefore, angle C is going to be bigger than angle B. This is what it is. Now let's see. They do not call them angle A, B and C. They actually give them names. So what you have to do at this point is to go back to the original picture that they give you and replace these names. Instead of calling them angle A, B and C, let's put their names as they assign them. Angle A is called X. Angle C is called Z. I'm going to erase this arrow so that we don't, it gets too crowded. I'm going to erase the arrows. Angle C, they call it Z. So angle C is Z. That means Z is larger than angle B, which they're calling Y. There you go. That is a fact. Same thing here. Angle A is X, angle B is Y, and angle C is Z. Okay, again, angle Z is going to be larger than angle Y. And since they're asking us which of the following must be false, without even looking at the answer choices, we do know now for a fact that there are only two ways they can represent the correct answer. And those two ways are either the correct answer will say that Z is smaller than Y, which is false, or it will say that Z is equal to Y, which is also false. Since we are looking for a false statement, there are only two ways you can represent a false statement. We are looking for something which will say Z is smaller than Y, in which case that will be the right answer because that will be the false statement, or we are looking for a statement which says Z is equal to Y. And that will also be false because we know Z is bigger than Y. Let's look at the answer choices. Oh, there you go. They do not say that Z is smaller than Y. There is no such answer choice there. But there is one answer choice that says Z is equal to Y. Well, Z is bloody well not equal to Y. Bloody well does not equal Y because we just said to ourselves that Z is bigger than Y. There you go. That's your answer. Answer is E. Answer is E. All the other statements that you see there may or may not be true depending on how you draw your picture. Do you understand? Which is what makes this question level 5. Let's go to the next one, number 13. I'm done with this one. I'll give you a chance to absorb it while I absorb my tea. Listen, before I forget it, when I was reading the punchline was, which of the following must be false? And I read it in a very cursory manner. That's not how you should read the punchline. You should slow down and take your time and emphasize the most important word in the punchline. I should have read it as, which of the following must be false? Emphasize the word must. I, on the other hand, read it in a very cursory manner. Let's learn that word, shall we? Cursory. I believe we did learn it in our vocabulary lessons one day. Cursory. Why are these words not there? cursory. I remember teaching this word distinctly. Just give me a second. There are too many words starting with C. Just give me 5 seconds and I'll find it. I am almost 90% sure we learned it. Oh, cursory. There you go. Day number 22. Day 22. What does cursory mean? To do something in a cursory manner means to do something in a hasty manner. To do it in a hurry. Can you give me an adverb of cursory? I'm going to erase all of this thing. We're done with the problem. So let's do the vocab. While you're thinking about it, can you give me an adverb of cursory? Think about it. If you do something in a cursory manner, if one does something in a cursory manner, one is said to have done it. If one does something in a cursory manner, if one does something in a hasty manner, one is said to have done it cursorily. Cursorily. You have to slow down in order for you to be able to say it properly. Just like if one does something in a hasty manner, one is said to have done it hastily. Cursorily is the adverb. The word abeyance is something we already learned also before. It's just to put something in abeyance, to keep something in abeyance. We don't say to put something, we usually say to keep something. To keep something in abeyance is just a very fancy way of saying, I'll deal with it later. I don't want to deal with it right now. Let's put it aside. Let's put it down, let's put it down, let's put it aside. We'll come to it later. Abeyance. So when I said the word cursory, I said let's keep the word cursory in abeyance. It turned out that abeyance itself turned into a vocab word. Let's learn it. And that was abeyance. I'm looking at my list of A words. Aberration, abeyance. Day number 9. Day 9. In case you're interested in improving your vocabulary, and I shouldn't have said it like this, because why the hell would you not be? You want to improve your math score, which is why obviously you're here. You want to get a better score in math in the SAT. Well, obviously you want to get a better score in the reading part. And one of the most important ingredient in the reading part, the most crucial element, is having a decent vocabulary. You must improve your vocabulary. On my channel, you will find some vocabulary videos. There are 60 of them, about 60 or so. Go through them. See if you can find something worthwhile to learn. Do you understand? Give a few of them a try and decide for yourself. Anyway, let's do the next one. Number 13. Number 13 is a level 4 question. It's not an easy question. It's a level 4 question. It's an algebra question. And whenever I come across a hard algebra question on the SAT, I always make a point of doing it without the algebra. Because if you try to do this algebraic problem in the algebraic way, in the traditional way, conventional way, orthodox way, in a geeky way, in a nerdy way, in an academic way, you're more likely to make mistakes and it will take you longer. The key here is to convert this algebraic problem into a very simple arithmetic problem. And how do you do that? How do you convert an algebra problem into an arithmetic problem on the SAT? It's very simple. Don't use the variable. Plug in the numbers for the variable. Plug in your own numbers for the variable and solve the problem based on those numbers. If the problem says Michael is X years old, when was the last time you met Michael who was X years old? Make Michael 20-year-old. Jennifer is Y-year-old. Well, I never met Jennifer Y-year-old. Give her some age. Pretend that she's 18-year-old. If the problem tells you that Jennifer is younger than Michael, make Michael 20 and make Jennifer 19 or 18 or 16 or 10, whatever you like. Solve the problem based on those numbers. Get the punchline. Get to the punchline. Once you have your answer, once you have your punchline, go through the answer choices and see which one matches with your answer choice based on the numbers that you plug in for the variables. And that's all. That's what we're going to do here. So, question, they're telling us that n is a positive integer and 2 raised to n plus 2 raised to n plus 1 equals k. Let's plug in n equal to 3. But you must remember throughout the problem what you plugged in, what values you plugged in for the variables. You understand? Don't lose track of them. I'm going to plug in 3. So 2 raised to 3, 2 raised to n plus 2 raised to n plus 1 is 3 plus 1. 2 raised to 3 is 8. And if 2 raised to 3 is 8, then 2 raised to 4 must be 2 times 8, which is 16. 16 plus 8, I know 10 plus 16 is 26, so 8 plus 16 must be 24. Oh, there you go, that's our k. That's our k. K equals 24. based on if n equals 3, k equals 24. And the question simply is, what's the value of, this is the punchline, what is 2 raised to n plus 2, n plus 2. Well, our n is 3, so it's 3 plus 2, 3 plus 2 is 5. Well, we already know that 2 raised to 4 is 16, and if that's correct, then 2 raised to 5 must be 32. 32 is our punchline. Listen, I just put a box around this thing. I'm going to get rid of the box and I'm going to tell you why. Box to me, putting a box around something in the real exam on the SAT, to me is very sacred, it's very holy, it's very special. You put a box around the punchline, nothing else. This is our punchline. The punchline is what they are asking. The question here is, what's the value of 2 raised to n plus 2? And if n is equal to 3, then 2 raised to n plus 2 is 32. That's the answer. That's what I'm looking for. We're not looking for 24. We're looking for 32. Any answer choice that works out to be 32, that's our guide. Let's go through them. Answer choice A says, but remember k equals 24 obviously. Remember k equals 24 and n equals 3. You must keep that in mind. Answer choice A says k minus 1 over 2. Well, k minus 1 is 23. 23 over 2 is not going to give us 24. It's not going to give us 32. This does not equal 32, obviously. Answer is not A. Let's look at B. B says 4 times k. 4. Let me do the B up here. Let me do the B up here. B says 4 times k over 3. 4 times k, which is 24, over 3. If you divide the top and bottom by 3, how many 3's in a 24? 24 has 8 3's. 24 has 8 3's. And 8 times 4, voila, 8 times 4 is 32. There you go. That's our answer. I got it. We found it in the second try. Of course, sometimes the answer turns out to be E. In which case, you just have to keep on going until you find what you're looking for. We're looking for 32. And it turns out B is 32. That's it. That's your answer. You cannot have 2 right answers. There's not going to be another one that's going to give you 32. You understand? That's it. We're done. Now listen, if you like, just for learning purposes, not for the real exam. This is not something you will do in the real exam. But just for learning purposes, if you like, I can show you how to do this question in the algebraic way, in the traditional way, orthodox way, in the geeky way, in the nerdy way, classical way. Would you like that? Let's learn it, shall we? It doesn't hurt. I need the room, so I'm going to erase everything. Again, I'll give you a second in case you want to pause this video or whatever you like. There you go. What you must understand is that I'm a nice, caring person. You understand? Whenever I feel like I want a sip of tea, I feel like giving you 5 seconds to absorb everything. You understand? So let's do the same problem in the classical way. In the classical way and the algebraic way, it's only meant for people who are very good at algebra. It's not meant for everybody. I'm not going to explain every single excruciating step in the algebra, because if I have to do that, then there's no point in doing it algebraic way. Don't worry about it. I'm just going to do it without actually explaining too much. So here is what it is. 2 raised to n plus 2 raised to n plus 1, we are told, equals k. 2 raised to n plus 1 can be written as 2 times 2 raised to n. And here we have 2 raised to n equals k. This thing that you see here is same as a plus b times a, if you like, equals k. Here a equals 2 raised to n. And what do you do when if you have something like this, a times a plus b times a? You can take out the a common. You can take out the a common, and here in this term we are left with 1, because 1 times a gives you a. And here, out of this thing, once you take out the a, we are left with b. Again, because a times b will give you b times a. That's exactly what we're going to do here. We're going to take out 2 raised to n common. We're going to take out a common, 2 raised to n. See, this is the part I didn't want to explain. So let's take out 2 raised to n common. So we're left with 1 plus 2 equals k, which of course is same as 3 times 2 raised to n equals k. Now the question is, how much is 2 2 raised to n plus 2. 2 raised to n plus 2. So we have 2 raised to n, we don't have n plus 2. So let's multiply this side by 2 raised to 2. Multiply this side by 2 raised to 2. And if you're going to multiply this side by 2 raised to 2, we have to multiply that side by 2 raised to 2. And now we have a base of 2 here, we have a base of 2 here. So this is same as 3 times 2 raised to n plus 2, which equals 2 raised to 2 times 4k, which is same as 4k. 4k. Almost done. We are interested in this part. So let's divide both sides by 3. Divide both sides by 3 and we find that 2 raised to n plus 2 equals 4/3 k, which is exactly what we found in a non-algebraic way. The answer is B. Let's do the last problem on the page, okay? It's taking too long. Number 12. Of course, these are taking too long because they are hard questions, obviously. Number 12. I was saving number 12 until the very end. This is why I went in the reverse order for a reason. Number 12 is a funky question. It's a very interesting question, but it's a very funky question. You will see in a second why. Because there is nothing at all that we can do in terms of mathematical solution. There really isn't. Here's what's given us, okay? Watch. They gave us a rectangle. They gave us 2 rectangles in a circle. I want you to pretend that this is the rectangle they're talking about. In the rectangle that they give you, they tell you the perimeter of that rectangle is 12. Can you tell me what's the perimeter of this rectangle? It's a 6-inch ruler. Well, if it's 6-inch ruler, this is 6 and this is 6, and this is 1 and this is 1. This rectangle has a perimeter of 14. You can either change that number from 12 to 14 in the problem, which is okay to do. It's not going to change anything. Or you can pretend that this has a perimeter of 12. Either way, doesn't matter. This is my rectangle, and there are 2 of these rectangles inscribed in the circle. So I'm going to draw the circle first. Okay? Watch what happens. Just watch what happens, okay? I'm going to draw it exactly, and I have to draw it a little bit longer so that they can fit in there. There we go. I'm going to draw one more. Again, I'm going to extend it out just a little bit so that they can fit in nicely. Here's my circle. Okay, watch what happens. Here's my rectangle. You see, it fits right in. Okay, it does not exactly, but just pretend it. That's the rectangle sitting right here. Another rectangle is sitting like this, horizontally. One is sitting vertically, one is sitting horizontally. And what they're asking here is that, how many such rectangle can you fit in there? It says, how many other rectangles with the perimeter of 12 can be inscribed in this circle? Let's find out, shall we? Watch what happens. Just watch what happens. There's no mathematical solution I can present to you. Just watch and learn. Here is one. Here is one rectangle that can fit in this circle. Are you ready? Here's another one. Here's another one. Here's one more. Here's another one. Here's another one. Here's back to the horizontal one that they give us. Here's another one. Here's one more. Here's another one. Here's another one. Here's another one. How many are there? How many rectangles can you fit like this in the circle? If one of these rectangles fit like this, if you are able to inscribe that in a circle, then you are able to inscribe million other. You just have to rotate it little bit, little by little by little by each. They will fit perfectly. They will fit perfectly. There are millions of them. There are infinite number of rectangles of this set perimeter that can be described because they are all identical. They are all identical. The answer here is, how many can you fit in? The answer is the infinite number. Now, if you find one answer choice that says infinite numbers, that's your answer. And the answer, of course, is more than 4. The answer is E. We are finally done with this page. I will see you tomorrow, okay? Bye now.